morning. Welcome to
Math Problems number 35.
Math Problems number 35. Alright, are you excited for this one?
Yeah.
What have you been doing before this video?
I've been spinning around and around getting dizzy.
Spinning around and around and around getting dizzy. Okay. Great. Don't be dizzy.
Okay.
Okay. So we were talking about a new section in Art of Problem Solving's pre-algebra book today. It's a really cool section about divisibility rules. So we're learning about when a number is divisible by another number. So we're going to be able to quickly figure out, like, by the end of the section, is 72 divisible by 3? 72 by... Yeah. So is 72 divided by 3 an integer? We're not going to know what it is necessarily, but we're going to be able to tell really quick if 72 is divisible by 3, which means 72 divided by 3 is an integer. But we didn't get there today, but we did talk about a few numbers that are a little bit easier than 3. 2. How can we tell if a number is divisible by 2? For example, is 2,913 divided by 2, does this equal an integer?
Well, I don't think so, because if you're a multiple of 2, you have to be even.
Aha! And this number is?
Odd.
Odd. Would it make sense for an odd number divided by 2 to be an integer?
No.
Oh, that would be pretty odd, right?
Yeah.
So, okay. So what do you think the rule is for when a number is divisible by 2? An integer is divisible by 2.
If it's divisible by it, it has to be even.
That's right. So for dividing by 2, it has to be even. Let's do 10 next. 10's a pretty easy one. Is 4,310 divided by 10, is this an integer?
I think so, because it ends in a 0.
Okay. So why does that work? Why does that work for 10? Why do multiples of 10 have to end in 0?
Well, because, some multiples 10, 20, 30, 40, 50, and they all end in zeros.
Okay, it seems like they all end in zeros, yeah. Because 10 ends in a 0, when we multiply 10 by an integer, it's
an integer.
Yeah, it is an integer. It looks like they all end in 0. So it looks like this is the rule for 10. If it ends in a 0, it's divisible by 10. If it's an integer that ends in a 0, it's divisible by 10. That's all. That's what I mean. Okay, now let's talk about 5. The divisibility rule for 5 is 2,916 divided by 5. Does this equal an integer?
No, because multiples of 5 end in 5 or 0.
Ah, multiples of 5 end in 5 or 0. So I can tell right away that that's not divisible by 5. No. No. But what's a number that is divisible by 5? Why don't you write one down?
So... that is divisible by 5.
Good. 3,820 is divisible by 5. And we learned about our first difficult one, 4. Okay, so how about a number like 2,854,912? Whoa! Does this equal an integer? Seems pretty hard, right?
Well,
but there's a special rule.
4 times 25 equals 100.
We know the special thing about 4 is 4 times 25 equals 100. So we know all multiples of 100 are multiples of 4. So that means we know 2,854,900 is a multiple of 4.
But what about the 12?
Now we just have to add on a 12.
Which is a multiple of 4.
Multiple of 4. Multiple of 4 plus a multiple of 4 equals
a multiple
of 4. So all we have to do is check the last 2 digits. So for no matter how complicated an integer is, we just have to check the last 2 digits. And because the hundreds are already divisible by 4, so we check the last 2 digits, and if they are divisible by 4, then
it's a multiple of 4.
How cool is that? This is pretty neat. So in the next couple of days we'll learn some more complicated ones. My guess is 3 and 9 and 6 are next. They have some neat rules. Alright? Good job, sweetie pie. You still dizzy?
Nah.
Nah? Alright.